Hello friends, uh, now I am discussing the question was asked in GATE 2005. A cantilever beam carries the antisymmetric load shown where W0 is the peak intensity of the distributed load. Qualitatively, the correct bending moment diagram for this beam is. So that is the beam where the load W0, it is uniformly varying load up to length L, and now the antisymmetric loading, that is called the uniformly varying load up to length 2L. A to B is a cantilever beam. So we draw the bending moment diagram for this cantilever beam. You have to understand about the basics of the bending moment and shear force diagram. We know the slope of the shear force diagram about the length x, that is given the load. Slope of the shear force, we obtain the load at that any point, and the slope of the bending moment diagram at any distance x, we obtain the shear force. Okay, so we draw the bending moment diagram over the length L, it's a middle length, and up to length 2L. It's point A, it is the point B. Okay, so if we draw the bending moment diagram, we discuss about the shear force in cantilever beam. Point B, around the point B, in the right of the point B, no shear force will act. So according to equation, suppose we take equation 1 and equation 2. In the equation 2, the slope of the bending moment diagram equals to shear force. If the point B there is no shear force, so the slope of the bending moment diagram becomes 0. If we draw the bending moment diagram, slope of the bending moment diagram is 0. It is the uniformly varying load, so shear force will be the parabola, and the bending moment diagram will be the cubicle. So we draw the cubicle shape bending moment diagram. Shear force, the bending slope of the bending moment diagram becomes 0 at the point B and is obtained up to length L. Okay, cubicle shape, it's a cubicle, not a parabola, but it's cubicle. About the length L, the shear force will be the maximum, so slope of the bending moment diagram will be a maximum. Slope of the bending moment diagram will be maximum, and after the length L, the shear force will act and the slope of the bending moment diagram will decrease. So after the length L, there will be just like that. Right? So this is the bending moment diagram of the uniformly varying load. Okay, where here is no shear force, so slope of the bending moment diagram becomes 0. Slope of the bending moment diagram becomes 0 because a tangent, if we draw the tangent at any point in the bending moment diagram, that is which gives the slope. Okay, so there is the tangent is, I am making an angle 0 degree, so the shear force at the point B is 0, and after the shear force will increase, the tangent at every point will make an angle uniformly increasing. At the point at the length L, the slope of the bending moment diagram become maximum and making an angle theta which is greater than this angle. And the point of A, the shear force will become 0, so slope of the bending moment diagram is 0 and making an angle 0 degree. So this is the finally bending moment diagram of the uniformly varying load. Thank you, friends.